Okay, here's an example where they give us a polar equation and they want us to convert it into an equation in rectangular form. Now, at first glance, it looks like, ooh, how in the world am I going to get x and y into that? Well, you might think immediately jumping in and say, well, when we know the conversion, we could use r equals x squared plus y squared, right? And so we know r is 2, so there we go. And so what does this represent? R squared. So this is going to be 4. So it represents a circle, right? A circle centered at the origin with a radius of 2. Right? So that was pretty easy. That was pretty straightforward, right? But think to yourself, and this is kind of going towards the way to kind of think about some of this stuff. If this is polar form, right? There's no theta. Okay? So what is this saying to us in polar form? The equation's saying that regardless of the angle, theta, they don't even give it to us. So theta can be anything. So regardless of what theta is, whatever angle that you want to use, the radius is always going to be 2. So when we think about that, it's like, okay, no matter what the angle is, no matter what angle I use, the radius is always going to be 2. So what does that trace in my mind's eye? Well, it traces a circle. Aha! So I know it's a circle centered at the radius centered at the origin with a radius of 2. And so then, in that case, it makes sense that, hey, then I'm going to use what? R squared equals x squared plus y squared, right? Where I get 4 equals x squared plus y squared. Okay. Now, what about this one? Let's do another one. Let's do this equation. So now in this case, think about it. There's no r given, right? So that means regardless of the directional distance, the angle theta is always going to be pi over 3, no matter what. So r could be 0, r could be positive, r can be negative. The angle is still going to be pi over 3. So what does this represent? This represents a line. A line that goes through the origin and has an angle of pi over 3. Okay? So if I was going to draw something like this, it would be drawn something like this, where, let's say I have some circles here, and it's going to be, what, pi over 3, which is 60 degrees, so it's going to look something like that. Okay, so now, how do I convert this into rectangular form? Well, I'm going to use the tangent of theta, right? Because I need x and y in there, and all I have is theta. So I'm going to use tangent of theta equals x over y. Sorry. Y over x. Now, what's the tangent of pi over 3? Well, tangent of pi over 3 is, excuse me, square root of 3 over 2 equals y over x. Or excuse me, I'm sorry, not 2. Square root of 3 over 1. Okay, so that means what? If I solve for y, right, that's what I want to do, so y equals square root of 3 times x. And so now this is the rectangular form, the rectangular equation of the graph. All right. Now let's do one more. And let's say we're given this. R equals secant theta. Now here's the thing. The last two are pretty straightforward. Not too hard to figure out. This one, it's going to take... It's not obvious from inspection that what we should do. So we're going to use the relationship of cosine, right? So what we do notice here, this is equal to 1 over cosine theta. So I'm going to use the relationship of x equal to r cosine theta. Okay? Now, since this here is cosine r, what I'm going to do is I'm going to multiply both sides by cosine, right? And so if I do that, then what do I get? I get 1 equals r cosine theta. And look at that. Now I get 1 equals x, or x equals 1. And so that is the vertical line, right? So now I have x equals 1, which is the vertical line at 1. So this would be x equals 1. All right, not bad. And again, we would want to have concentric circles since it's supposed to be, we're converting into rectangular form, so I guess it's okay.